Hello, everybody. It's Dr. Jamnadas again from Cardiovascular Interventions in Orlando. And today, I'm going to talk about a very important subject, a subject that has really intrigued me since I was a fellow, and it's all about prevention again. But the question is, what is it that's causing the inflammation in the arteries? So when I was a fellow, I used to ask my professors that and never really got a straight answer. And today, after doing extensive work and research and experience in 35 years in this field, I wish to share some of what I've learned with you all. And in my previous lectures, we talked about the role of the endocrine system. So we talked about hyperinsulinemia. We talked about the hormonal changes that result in metabolic syndrome. So remember, metabolic syndrome is high sugar, high blood pressure, increased weight, low HDL, and increased abdominal girth with a lot of fat around the abdomen. And this leads to atherosclerosis. So as a result, we talked about the dietary changes. We talked about the benefits of intermittent fasting, time-restricted feeding, and we talked about how to eliminate all processed foods and refined products and mostly sugar. And I've been doing this now for many years, and I've seen dramatic responses in the office. But I didn't fully understand the mechanism. So today I want to share something new with you all, which I think is very important. That the upper part of the intestine deals with the calories that are absorbed into the body, the nutrients that are absorbed into the body. And then the colon, further down, was really felt to be just a depository of all the fiber. And as I did more and more research, I found out that actually, why would we have such a large colon full of fiber and undigested matter? And I found out that it's not. There's actually a ton of bacteria in there. Bacteria. So there's probably about 80 trillion bacteria in your colon. And there's 10 trillion cells in your body. So the question is, what are the bacteria doing there in the gut? Did they just happen to come there? Why are they there in the first place? How did they get there? And if they're in there, how come they're not getting into your bloodstream? And if they do get into your bloodstream, are you going to get sick? Or maybe a little bit of it is getting into your bloodstream and making you sick and causing atherosclerosis and metabolic syndrome. Could this be a problem? Could this be an answer? Do the gut bacteria have only one type? Or are there many types of bacteria in the gut? And there's also viruses, by the way. There's probably about 380 trillion viruses in there. And of course, there's some fungi as well over there. So what are they doing over there? And when I'm telling my patients, all of you, to change your diet, stop eating so frequently, stop eating processed foods, and start eating whole foods, well, what am I really doing to the bacteria down there? And maybe some of these benefits are because of the bacterial changes rather than just the hormonal changes occurring higher up with the absorption, because the fiber, as we know, decreases the absorption of sugar, so you get less of an insulin spike. And because you get less insulin spike, you're not going to get insulin resistance. If you don't get insulin resistance, you're not going to get a fatty liver, you're going to lose weight, and you're going to feel better. And we've seen these results. But I think there's more to it than meets the eye. So the question is, what are the bacteria doing there? And what kinds of bacteria are there? And how many different varieties are there? And how is my bacteria different from an unhealthy person, or an obese person, or someone with metabolic syndrome, or someone with chronic inflammatory bowel disease or autoimmune diseases? And I started doing more and more research. So this is going to be the first of many, many videos that I'm going to put out. And to show you that when you are making these changes that I've been recommending to you all, you're actually not just affecting your hormones, you're actually drastically changing the entire metabolism in the body. So by the time the food gets down to the colon, you're really left with the undigested complex carbohydrates and fiber. And we've always heard that fiber is good for you, but nobody really knew why. I mean, it's just because it gives you a big poop? I mean, so what, do you have a big poop? How does that make you live longer? How does that lower your blood pressure? How does that decrease your chances of developing metabolic syndrome? We really don't know the full answers, but it is the fiber that is feeding the bacteria. That's one part of the story. That when you eat a meal that is full of natural fiber and different kinds of fiber, then that's the food for the bacteria in your gut. And then the bacteria in turn must be doing something for you. So if it's a commensal relationship, it's in there, it's not going to harm you, it's not going to do you harm unless it gets into your bloodstream. How does it stay inside? What products are the bacteria producing? We'll go over all this in my future videos in great detail. But today, I want to tell you why this is important. The gut bacteria, we know, produce substances. We know that help the gut lining so that the gut lining is healthier. We know it affects the immune system because your immune system is keeping the bacteria there and letting the food come in. So we know that it's affecting your immunity. And I told you that heart disease is an inflammatory condition. Coronary artery disease is inflammatory. Congestive heart failure, myocarditis, cardiomyopathy, these are all inflammatory conditions, and they're associated with metabolic syndrome and fatty liver, and all the inflammatory markers are really, really high. So we know there's inflammation going on. So we know that there's a multitude of factors that are going on in your gut, and let's try to explore them. So what's the mechanism? What is it that I'm really after? I want to see why. Why is it that some patients are losing weight, but they're still sick and they're inflamed? So they've lost their weight. The insulin levels have come down. But they're still sick. They still have inflammation. They may have inflammatory bowel disease. They may have joint problems. They may have mental fog. They may still have high blood pressure. They're still getting progressive atherosclerosis. They're getting more and more coronary artery disease. So when we look at the mechanism, there's a thing called lipopolysaccharides that have really intrigued me. And lipopolysaccharides are the bacterial wall linings. So the lining of all the bacteria, the walls of them, they call lipopolysaccharides. And I'm going to call them LPS for short. So we have now shown that when patients have lipopolysaccharides in the bloodstream, then that causes inflammation. The lipopolysaccharides then circulate around the body. Of course, first and foremost, they go to the liver. And when they go to the liver, they cause inflammation in the liver. And they cause fatty liver changes. Which brings me to my observation myself that I have seen patients who've brought the insulin levels down, who've lost weight, but they still have a fatty liver. I have seen patients who've got severe coronary calcification and they do not have diabetes, yet they have a very fatty liver. And they don't have alcohol. They don't have chronic liver disease like hepatitis B or hepatitis C, but they have a fatty liver. And all of a sudden the light bulbs go off that this fatty liver is possibly caused by the inflammation that's coming from the gut. And it's these lipopolysaccharides that are supposed to stay in the gut, are getting into the bloodstream and getting into the liver, and then in the liver creating the fatty liver. And then, of course, it moves on to the rest of the body. In the liver, it'll also cause insulin resistance. So the lipopolysaccharides cause insulin resistance at the level of the muscles and at the level of the liver. So now things are beginning to kind of make more sense, that if you have lipopolysaccharides leaching into the bloodstream, going to the muscles, causing insulin resistance at the level of the muscles, all right? In the liver, it's causing the fatty liver, also causing insulin resistance and inflammation. Interleukin-6 levels go up, tumor necrosis factors go up, and a low-grade inflammation starts because those bug coatings are not supposed to be in the bloodstream. So then these lipopolysaccharides also get into the brain. And we know that the blood-brain barrier is supposed to keep all these things out. But there's evidence to show that when lipopolysaccharides get to the brain, they can actually breach that. And they can actually get into the brain and cause inflammation. And when they cause inflammation in the brain, in the astrocytes and the cells that are in the brain, you can actually see that on CT scan showing small vessel disease. And this has intrigued me because these patients that come to me with metabolic syndrome, coronary artery disease, I do a CT of the head because oftentimes they have depression. And the only thing that comes back positive is evidence of small vessel disease. And then when you ask my neurology friends, what does all that mean? There's no real answer. So wait a second. So you're getting small vessel disease in the brain. These patients have the phenotype of depression. Well, when in the animal models, in mammals particularly, when they're sick, they have the sickness syndrome. The sickness syndrome means they get withdrawn, they don't want to interact socially, they just want to stay on their own. That's nature's protective mechanism that, hey, listen, you're sick, you need to heal, so you need to kind of isolate yourself. So could this be a protective mechanism that is built into us, that if you have lipopolysaccharides getting into your bloodstream, in turn it's going to affect your brain and cause depression? Now look around. Depression goes hand in hand with coronary artery disease. I've said that in all my talks. There's a 400% increased incidence of depression when you have coronary artery disease also. So this is a systemic disease. This LPS is causing a systemic problem. In the brain, it's causing mental fog, small vessel disease, depression, and then in the liver, it's causing the fatty liver, as I said. In the muscle, it's causing insulin resistance. And at the level of the hormones, it causes insulin resistance, more weight gain as well. These lipopolysaccharides also affect your immunocytes. So your immune system gets stimulated. So when your immune system gets stimulated, now you're going to get all the inflammatory markers going up in your body. Okay, and we've seen this with coronary artery disease. We see this with the problems in the metabolic patients. So lipopolysaccharides, why would they cross into the bloodstream? And why is it that a lot of my patients are getting better with diet? And I think it's because when you're eating the fiber, so there's many factors, but when you're eating the fiber, you're fueling the right type of bacteria in your gut. So the right bacterial species and strains grow, and they in turn have a beneficial effect to us because they heal the intestinal lining. And we'll go into this in great detail in my detailed talks, but there's things called short-chain fatty acids that are produced by the bacteria, which in turn help to heal the gut lining and prevent this leakiness of the intestinal lining so that the lipopolysaccharides don't leach into your bloodstream. And there's lots of mechanisms. I'll go over that in great detail with all of you in my future talk as well. But to know for a practical purpose that eating the right kinds of whole foods are of benefit to you, not just because, oh yeah, I'm getting the fiber and therefore I'm attenuating my insulin response. It's also because you're feeding the bacteria. You're eating not for yourselves, you're eating for yourselves and your bacteria. So then that brings me to another question. What else do these bacteria want besides different types of fiber? And by the way, it needs a variety of fiber, not just one kind. So you want to eat a variety of different fiber sources. But the other thing are phytonutrients. Now these phytonutrients are, the flavonoids and all the different colorings that we see in foods that we know are beneficial are actually not for us. They're for our bacteria, because they foster the growth of the right kinds of bacteria in your gut and a good variety of bacteria. It's not just one kind. There's well over 2,000 different species of bacteria in your gut, and you want them all because they keep them all in balance. And that's what results in a healthy gut lining. So they want the right foods. They want to eat the fiber. They want to eat the phytonutrients as well. And then the other thing is that we need to make sure that we're not destroying that population down there. And in a separate video, I'm going to show you how the sweeteners that you are eating, the antibiotics that you are taking, and the antibiotics that are in all your foods that's contaminated are actually destroying the bacterial flora in your gut. So if you have a gut flora that's been demolished, or the variety and the diversity has been demolished by your lifestyle, your eating, your antibiotics and your sweeteners and chemicals and toxins that you put in your food, then you can now see a picture that, well, my gut bacteria flora diversity is gone. They're not producing the right substances for me to heal my gut. I'm developing a leaky gut, and that's causing the endotoxins, or lipopolysaccharides. Another word for them is endotoxins, and they get into the bloodstream. And I call this metabolic endotoxemia. Endotoxemia, that means toxicity in your bloodstream. Coming from what? Bacterial products that should not be in the bloodstream. So these bacterial varieties that we have in our gut, it's very complicated. from everything that I've been reading, it's not just the species, because different species can then also change what they produce. And therefore, the ultimate effect is going to be what chemicals are those bacteria making that are making your gut better, not just the species. So we can identify the species, but it's also the products that they are making that's important. So there's very interesting studies on this, and I'm just going to tickle you with a little bit of it right now because we're going to go through it in a separate video, is that you can take a stool sample and look at it and you can predict obesity. So there is a microbiome meaning the total population of bacteria in your gut, that identifies obesity. And what that really means is that those types of bacteria are more able to break down the carbohydrates and absorb more calories, number one. Number two, they cause metabolic changes in your body. So they cause metabolic syndrome. And metabolic syndrome in itself, with hyperinsulinemia, will make you gain weight as well. So just to tickle you a little bit further, if you take that microbiome and you transfer it into a lean person, that lean person can become obese. And those studies have been done, both in rats, and we also see them in human beings. So fecal transplants are not something that new. They are now actually giving us a lot of insight into how our microbiome is actually changing our metabolism, metabolic syndrome, inflammation, and ultimately, what do I want? I want to see that metabolic syndrome is out of the picture for my cardiac patients, because that's what's driving coronary artery disease. So being a cardiologist, my particular interest in lipoproteins, lipopolysaccharides go even beyond what I've just told you. You know about cholesterol, right? The LDL. So I'm going to tell you a little bit about the LDL. The LDL that I'm very aggressive about is small, dense LDL. So in the advanced lipid panel, why do I look at small, dense LDL? It's because when these lipopolysaccharides get into the bloodstream, they cannot just free float in the bloodstream. So they are swiped up by immunocytes, of course, but one of the things that they are swiped up by are lipoproteins. These lipoproteins is LDL, but the LDL doesn't have a room on it. So it has to displace the cholesterol, and then the lipopolysaccharide takes its place and now has created a small, dense LDL particle. We know that it is the small, dense particles that cause atherosclerosis. Because they can get easily oxidized, they're taken up by the macrophages, and then they get foam cells. They can actually get into the endothelium of your blood vessels and cause atherosclerosis. So it is the lipopolysaccharides that are taken up by the LDL, creating small, dense LDL, which then in turn are recognized by your immune system, swiped up, creating foam cells. They also get stuck to the endothelium of your blood vessels and cause atherosclerosis. So why is this so important? Because I have seen that when my patients' LDL levels, gross levels are fine, but they're still getting progressive disease. So then I order the advanced lipid panel and I see small, dense particles. If I simply went with the total LDL, I would have said, oh, everything is fine and hunky-dory, but the patient keeps coming back with more disease. Small, dense LDL almost invariably associated with a fatty liver, which is almost invariably, unless you have hyperinsulinemia or other reasons to have a fatty liver, associated with a gut problem. And you have either due to dysbiosis, the term that I will use over and over again in my future lectures with you, because this is the first intro, but dysbiosis, wrong bacteria in your gut, leaky gut, a dysfunctional gut lining, a lining that is just not working well, not only because of the bacterial products, but there's other things that we are doing that are destroying our gut lining. Even stress destroys your gut lining. So I know I'm going all over the place here, but look at this. You know that when you're stressed out, you feel it in your gut, and your gut grumbles. You may get some diarrhea. You may get even abdominal pain and all these things. Studies have been shown that this stress increases the lipopolysaccharide circulation in your bloodstream. How did that happen? One bad examination, one bad interview, and you're getting lipopolysaccharides into your bloodstream. It's because there's a big connection between the brain and the gut lining. Because ultimately, look, the gut lining is what's determining the outside world from you, yourself. So there has to be a big connection to the brain, and it's through the vagus nerve, which is the largest nerve in the body. So what happens is that this excessive stress in your brain works both ways. Your brain should know what's going on in the gut, but the gut also sends signal to the brain, vice versa. So what happens when you are stressed out? Your vagus nerve pours out, goes to the gut, and there it releases cortisol-releasing hormone, which then goes to the immunocytes in your gut, and 70% of the immunocytes in your gut, and causes release of some peptides from mast cells and other cells, which then destroy the lining. The porosity of the gut lining increases. So your gut lining becomes leaky. Now this is very scary. That means one episode of severe stress can cause leakiness of your gut for hours, and this has been shown in studies. So there are many factors: the bacteria crossing over, leaking of the gut, inflammation. It all seems to start with having a healthy lining. So you need to have a healthy lining, healthy bacteria, and then deal with the problems that these are all creating in the body. From the practical standpoint, right? From the practical standpoint, we've already made the inroads in this. We talked about eating the right kinds of foods. We talked about exercise. Exercise is very healthy for you. And we know that one of the reasons is it actually helps the gut bacteria in your gut lining. Sleep, bad circadian patterns affect the gut lining as well. It affects the porosity of the gut lining. There's an intimate connection between all these lifestyle factors, which we will go over in great detail. Each lecture that I'm going to do thereafter, from now onward, it's going to be about half an hour long, and we'll deep dive into each one of these factors. How does sleep affect your gut bacteria and its lining, for example? How stress does it itself, and how that affects everything, and of course all the dietary things that I've already talked about, and whether you can actually change your bacteria. And eating fermented foods, for example, is that helpful? Are probiotics more helpful than fermented foods? Well, I'll tell you right now, it's the fermented foods. Probiotics can be helpful in some cases. And then we'll talk about gastric bypass surgery and how those patients are amazing because they have a complete transformation of their gut bacteria. And that's what's causing the sudden reduction in their weight. Metabolism gets better. Complete reversal of type 2 diabetes. Complete reversal of type 2 diabetes. Inflammatory markers all go down. Fatty liver also gets better. So these entire changes are occurring. We think that it's gastric bypass. It's all to do with the bacteria. So I'm tickling you all with the idea that it's really coming down to this. And some people will say, well, a small amount of lipopolysaccharides get into the bloodstream anyway. Well, I think that's appropriate. That is, after every meal, you're going to get a little bit of lipopolysaccharides getting into the bloodstream, inevitably, because it's not 100% intestinal closure to the products. So you're going to get some. But that's how the body samples immunologically what is good, what's bad, what shouldn't be treated, what should be treated. So a little bit of LPS getting into the bloodstream has now been felt to be normal, but it's that pathological one that comes across, and when too much of it comes and too often. And maybe that's why my fasting is working so well with these patients. How come they're mentally also feeling better? How come the fatty liver is getting better with fasting? Because you're not getting that frequent LPS getting into the bloodstream. Every few hours, LPS getting into your bloodstream, causing inflammation. Because we talked about the frequent increase in insulin. Now I'm talking about the frequent increase in LPS getting into your bloodstream as well, causing a chronic low-grade inflammation in the bloodstream, the metabolic endotoxemia, as I was saying before. And then when you have insulin resistance, that compounds the problem, because one of the issues that insulin is supposed to do is it dampens the immune response to this low-grade LPS. But when you have constantly high insulin levels, you're not going to be able to dampen this response. So I think that there's so many exciting things here that I want to talk about. from the practical standpoint for all of you, because you're watching this channel, you have already probably implemented the dietary changes, which is stay away from processed foods. Do not eat artificial foods or foods that have chemicals in them that you can't even spell them. You don't even know what they are. If you can't pronounce that word in that food label, and first of all, if it even has a food label, it's suspicious. And you've already made those changes. Do not eat it, because it's not just affecting you. Much of your changes that are happening are because of the bacteria. Don't forget now, you're a symbiotic relationship with your bacteria. It's not just what you're eating. Almost 50% of the micronutrients in the body are probably produced by the bacteria and then liberated into you, meaning that your 21,000 genes are not enough to explain the complex physiology of the human being. But actually, you probably have another 4 million genes which belong to the bacteria that are actually doing the outsourced job for you. They're the ones who can constantly change as well their genome, because the half-life of bacteria, or the turnover, is only less than hours, in some cases, at most a few days. So it can adapt. The genome of the bacteria in your gut can adapt to what you're eating. This is amazing. And that's why we have such a variety of bacteria in our gut, because then they can adjust to what you're eating. I think we just didn't realize this. So that is why you want the widest variety of bacteria in your gut, and thereby they keep themselves in balance and they can handle anything that's coming their way, because their genome can adapt quickly. So let's be more mindful about what's going on in the gut. So as a cardiologist, I just want to stop this inflammatory cascade that keeps happening. And yes, we've started the diet and we started the fasting. And if we still have a problem, it's probably with the gut. And there may be other issues that we can fine-tune. And that's what these lectures will go over. How do you fine-tune them? Maybe it's the leakiness. Maybe it's an allergy to certain types of food. Maybe it's SIBO, which is small intestinal bacterial overgrowth, and you may need special treatment for that. Maybe you need a repopulation of your bacteria. And I'm telling you, that's coming down the road. We're already doing that for Clostridium difficile infections, where we do the transplant of fecal materials with very, very good success rates. So I think that stay tuned on this. We will go into each one in detail. And for those, I'll actually show you some slides and things so you can remember them and make it memorable. But this is my intro to my next series, which is going to be about inflammation from the bugs in your gut. So stay tuned. I hope that made you excited about the next series. Take care, and congratulations that you're already ahead of us by doing the dietary changes that I've recommended before. But now you'll understand how it's helping you even more. Take it to the next level. Take care, everyone. Bye-bye. When we look at this model of atherosclerosis, now we begin to have that aha moment that yes, I think we're onto something. That's why when we changed the diet, that's why when we made you lose weight, that's why when we gave you fiber in your diet again, we did something to you. This is huge. How did we get to this point? Where did we go wrong? Hello, everybody. This is Dr. Jamnadas from Cardiovascular Interventions in Orlando, and I'm back again talking about atherosclerosis, inflammation in the body, and what causes this inflammation. And like my preliminary lecture that I gave, that was the introduction. So today we're going to go and do a deeper dive into what is it? What are the mechanisms of inflammation? And very important, this came about kind of backwards. We knew that if people started eating non-processed foods, foods that have all the fiber in them completely as nature packaged it, and if patients stopped eating so frequently, so that, again, as nature planned it, you should be eating intermittently, occasionally, time-restricted feeding and intermittent fasting, we found that these patients were doing great. All of a sudden, we noticed that the weights come down, the fatty liver goes away, the sugar, diabetes goes away, the hemoglobin A1C comes down not by 0.3 like I showed in my previous lectures, but by 3.0. We can actually reverse diabetes, and the mental fog seemed to get away, and the joint pains got better, the stomach problems also got better, memory got better, sleep got better. And we talked about the hormonal effects of hyperinsulinemia and the benefits that you get from that. But there's more to it than that. And today I'm going to show you that all those changes that you all have made have solid scientific basis for it. And it's very complicated. It's to do with the microbiome, the gut, that is very important because there's so many bacteria in the gut. There are trillions and trillions of bacteria, probably more than 100 trillion bacteria in your gut. The question is, did you know that? Why are they there? What are they doing? Just passing time in your gut? 10 trillion to 100 trillion. 10 trillion human cells, 100 trillion bacterial cells. What are they doing over there? They got to be doing something. And they all have a genome. And this genome can change and mutate every day. So there's something more going on with these bacteria. And that's what today's talk is going to try to get into, the mechanisms. Now, we talked about this a little bit last time when I told you about lipopolysaccharides, LPS. So let's talk about that. LPS, lipopolysaccharides. Those are found on the bacterial wall. So the bacteria that are in your gut, the walls contain lipopolysaccharides. Now, these lipopolysaccharides should stay inside the gut. But instead, what happens, they get into the bloodstream. And here's the bloodstream here. And they get into the circulation. And they get into it because the gut, which is made up of cells, have gaps in them that can be created by the lipopolysaccharides, and they make a little hole in it and they get right through. They're not supposed to get through. So we're going to talk about the health of the gut that should prevent these bacterial products to get into the bloodstream in the first place. But number two is, if you have too many lipopolysaccharides from the wrong bacteria, the wrong kind of bacteria, then you're going to have a lot of LPS. So that will lead to increased LPS as well. See, the concentration of LPS will go up. Then the leaky gut will allow it to come through. LPS itself can also break the lining of the gut. Also, certain foods do it, and certain chemicals do it. Additives do it. And so do artificial products in your diet. They punch holes in you. Even non-steroidal anti-inflammatory agents punch holes in it. Which other agents? Artificial sweeteners do it. And if you have a wheat allergy or a wheat protein allergy, they can also punch holes in the gut. But stress can make holes in the gut as well. Just simple stress alone can make your gut more leaky. So the bottom line is, the wrong kind of bacteria we need to concentrate on. The leakiness of the gut we need to concentrate on. And then the LPS gets into the circulation. And when it gets into the circulation, the LPS, as we said, cannot free float inside the bloodstream. So what does it do? It attaches itself to the LDL molecule, the LDL. That's the cholesterol molecule, which you all know about, low-density lipoprotein. So when it knocks off a cholesterol piece from it, and it takes its place, now the lipopolysaccharide takes its place. Now you're going to create small, dense LDL. And you know from my previous lectures that that's been linked to atherosclerosis. So you see, this is where my interest is that this LPS causes this, which causes small dense LDL, which causes atherosclerosis. What else does LPS do? LPS does a lot of other damage. So let's go through that. LPS also goes to the intestinal lymphatic system. These are lymph cells over here. What are they doing there? T cells and B cells. That's your immune system. Well, because they are the border patrol. They are to make sure that these guys stay here and they don't get into the circulation. So the immune system 70% of the immune system is in the gastrointestinal tract, because that's the real border, and the patrol is done by the immune cells. So these are T cells, B cells, and of course there are also other kinds of immune cells over here. So this LPS, which is not a good molecule, goes and it can actually stimulate these immune cells. So these immune cells will then start producing molecules such as interleukin-6, tumor necrosis factor. These are inflammatory cytokines. You've heard this word, cytokines. Inflammation. When a patient gets COVID and succumbs to it, it's because there's an overwhelming cytokine storm. Too much of this inflammatory process, which overwhelms the body, causes intense vasodilation, shock, and then the patient demise. So, too much inflammation. So why is this? Because it sees that the LPS is a foreign material, and then there's stimulation of the immune system. So this is the immune system being overstimulated by these products that get inside. So it does cause an immune problem as well. What else does this LPS do? Well, LPS can also, in its circulation, affect many parts. It can go to the liver, and in the liver, it causes fatty liver, because of all this inflammation is coming into them. In the muscles, it will cause insulin resistance, which you all are familiar with now. I've been talking about insulin resistance. So when you have bad things going on in your gut and you're getting stimulation, the immune system is activated, the liver becomes fatty, and the muscles become resistant to insulin as well. So you get insulin resistance. When you get insulin resistance, what happens when you get insulin resistance? All the bad things, the weight goes up, and blood sugar goes up. You're basically getting metabolic syndrome. Triglycerides go up, and the HDL comes down. All these are markers of atherosclerosis. This is what's going on. Also, these molecules all circulate in the brain as well. And in the brain, they cause immune activation in the brain too. So you have your astrocytes there, you have a microglial cells, you get a breakdown of the blood-brain barrier, and it causes inflammation in the brain as well. And that results in, of course, symptoms such as mental fog, depression. Depression is associated with atherosclerosis. We know that. Patients who have heart attacks, there's a 400% increased incidence of depression as well. And the depression is the symptom of inflammation in the brain. We now know that depression is not just a psychic thing. No, it's not. It's an inflammatory condition. The phenotype is a depressive affect, but there's actual inflammation going on in the brain, too much inflammation. To that matter, even the myocardium, the heart, in congestive heart failure is inflamed, and you have immunocytes in the muscle of the heart, myocarditis. So you get this low-grade myocarditis in patients who have this, causes a stiff left ventricle. In congestive heart failure, you all know that you have systolic dysfunction and diastolic dysfunction. Diastolic dysfunction means that the heart doesn't relax properly. It's too thick or it's too stiff. And the reason? Because the muscle is infiltrated with inflammatory cells, inflammatory molecules that causes it to be stiff. Same way as the brain is full of inflammatory cells, your liver, a fatty liver, full of inflammatory cells. The fat that you see in metabolic syndrome, which is mostly in the viscera, if you did a biopsy of it, almost 50% of the weight of that fat is inflammatory molecules. So fat is not just fat. There's good, healthy fat, which is under the skin, for example, in some people, and we call them obese healthy, because they don't have any of the markers of inflammation. But when you have inflammation causing obesity, which I showed you there, you can, these patients have mostly, the fat is in the stomach area, in the viscera, and in the liver, around the pancreas. You do a biopsy of that fat, 50% of the weight is inflammatory cells. So just think about it. Why is that the case? Why is it? Because LPS, lipopolysaccharides, getting into the bloodstream, they actually get into the fat tissues as well. So when they get into the fat tissues, the body says, wait a second, this is a foreign material, this is a bacterial product. So it mobilizes all your immune cells to go into the fat cells to trap it. That's why the inflammatory cells are there in the fat. So this is inflammatory fat. Metabolic syndrome causes inflammatory fat. This fat is sick. It's full of immunocytes, interleukin-6, tumor necrosis factor, and these are just two of them. There's actually a whole myriad of them inside the fat cells. So this is an inflammatory process. This is not just simple obesity. And that's why it is so linked to atherosclerosis and heart attacks. Patients with fatty liver, they get heart disease. Patients with infiltrative fat, mostly in the belly, they get heart attacks. Patients who have depression, have inflammation associated to this, they get heart attacks. Patients who have insulin resistance, metabolic syndrome, get heart attacks. So when we look at this model of atherosclerosis, now we begin to have that aha moment that yes, I think we're onto something. That's why when we change the diet, that's why when we made you lose weight, that's why when we gave you fiber in your diet again, we did something to you. What did we do? We got the LPS down. How did we do that? We must have healed the gut. What else did we do? We changed the bacteria. We must have changed the bacterial population. Oh, so you repopulated my gut with the right bacteria, and you fixed the lining of my gut. So therefore, I'm not getting systemic inflammation. I think you're onto something right there. So this model that I'm talking about, this is huge. How did we get to this point? Where did we go wrong that all this started happening to us? So it starts in the gut. Hippocrates said all disease starts in the gut. So this model helps to explain the modern epidemic that we have. What's the modern epidemic you have? You don't have cholera, you don't have typhoid, you don't have smallpox, you don't have all those diseases, dysentery and typhoid. Those are all gone. But we've replaced them with low-grade chronic inflammatory diseases. These chronic inflammatory diseases include coronary disease, atherosclerosis. Atherosclerosis is one of them. Depression is another one. Mental illness, neurocognitive dysfunction associated with even Parkinson's, mobility disorders. In the bowel, inflammatory bowel disease, ulcerative colitis, Crohn's disease, small intestinal bacterial overgrowth, reflux disease, diverticulitis, all associated with the changes in our diet and inflammation, joint diseases, autoimmune diseases, rheumatoid arthritis. Now we recognize starts in the gut with autoimmune disease. So we are now realizing that there are so many chronic conditions that are afflicting modern man, all because of the wrong stuff that's going in the gut. And we didn't understand how, but we are now beginning to understand that it's the bacteria and the lining. And that's what's resulting in all these immune and hormonal changes, of which atherosclerosis is one of them. So if this is the case, our next portion of this talk is going to be, what can I do to heal my lining? What can I do to heal my bacteria over here? And how did my bacteria get so bad? So that's going to be this next portion that I'm going to talk about now. If you like this video, then this one is strongly recommended for you. But if you want to see the whole series, please click here. So wait a second. Are you saying that my brain development is dependent on my bacteria being there under the age of 1 while my brain is still developing, and it actually has an influence on my brain development? The studies have been shown, yes. So welcome back. Just to summarize what happened in the first portion, I talked about the LPS and the inflammation that's occurring in the body, either because we have the wrong bacteria, and the word I'm going to use is dysbiosis, and I'm going to talk more about this. So that was we covered. Now I'm going to talk about how did the bacteria get there in the first place, and what's wrong with them? What's wrong with your gut bacteria right now? Okay, so you said there's 100 trillion of them sitting around over there. So how did they get there in the first place? How come they're not everywhere else? Well, they are everywhere. So let's go back in history. So bacteria were here for billions of years before the mammalians came about. And our very design had bacteria in it. They were part of our development as we are today. And that's why we only have 21,000 human genes. Did you know that the fly has more genes than we do? The worm has more genes than the human. Oh, wait, what do you mean? You mean to say that an earthworm has more genes than you? Then says yes. Well, then how am I able to do everything that I'm able to do? I'm a human being. Yes, because you outsourced a lot to your bacteria. What do you mean outsourced it to the bacteria? What that means is that you are utilizing their genetic ability and their quick turnover and changes in their genetics that occurs in the bacteria to your advantage. Now, how did I discover and read all this? It's because I figured that all these chemicals in the body, where do they all come from? Is it all that I'm eating? Or is it all that I'm making? No, we realize that the bacteria are making a lot of this stuff. It's the bacteria. We've outsourced everything. They started outsourcing way before we started outsourcing. So that gave us the advantage that we didn't have to, because of our long lifespan as well, wait for beneficial mutations. The bacteria are mutating practically every 24 hours. So if there's a change in the environment and you're adapting to it, your bacteria are far better able to adapt to it because of their rapid turnover. The lifespan of a bacteria is only a matter of hours or days at the most. So they are more likely to have mutations that are going to be either beneficial or not beneficial to us. So the bacteria have been with us all along. But wait a second, when I'm born, I have no bacteria. None whatsoever. Well, the data now shows there's a little bit of bacteria even in the uterus. But it's insignificant. And your gut definitely has hardly any bacteria in them when you are born. So where did you get the bacteria from? Well, in a normal delivery, you come through the birth canal and mom already has all the bacteria there. Now, it's funny that those bacteria are to populate your gut. But you'd think that that population is very different. Did you know that in the last months of pregnancy, the entire bacterial flora in the birth canal changes? More lactobacillus, for example, because the mom is actually exporting bacteria and changing the population in the birth canal so that when you come out, you're going to be bathed in these new bacteria that she made specially for you, especially for your gut, specially designed for you to match also your genetics. So as you come through the birth canal, you then populate yourself. You populate your skin, your nose, your eyes, your ears, and of course your gut. And now these bacteria get into your gut. Second thing, mom, through breastfeeding, gives you further bacteria. There's actually bacteria in milk, mother's milk. Most people don't know that, but it's true. There are bacteria in them. And they also contain these oligosaccharides. So what are oligosaccharides? They are very complex carbohydrate molecules in mother's milk. Why? You can't digest it. I can't digest it. Nobody can digest it. The baby can't digest it. So why is that in the mother's milk? Well, it's not for you. It's for your bacteria. So your bacteria feed on those molecules because you're encouraging the growth of certain types of bacteria. So you attract and keep the bacteria you want in your gut depending on what you eat. That's why fiber is so good for you as an adult. Because when you eat the right fiber, you're going to attract the right population of it. I mean, that's nature. You give it the food, the right bugs will come over there. So you foster the growth of a good bacterial population in your gut. So this population, which is trillions and trillions and trillions, there's going to be good guys, bad guys. It's a mixture of everybody. It's what we call the landscape. The landscape is very varied. So the good take care of the bad guys, and they are all kept under control because there needs to be a balance. It's not just one species. There's multitude of species in the gut. So that's mostly how we get. Now, if you get a C-section, you're a little bit of a disadvantage. Why? Because you're not really getting all that bacterial load onto you. And next thing is, caressing a baby, holding a baby, breastfeeding the baby, family members coming, touching the baby. You are transferring your familial microbes to that baby. Now, why is that important? That's important because the data now shows that you actually make proteins in your gut that get secreted by your gut lining to attract the right bacteria. So the right bacteria there, you already have the genetics for those bacteria that you're not going to fight them. So you already programmed for a certain bacterial population that these guys are all my friends and I'm not going to mount a response against them. How did it happen? It happened in your genetics. Mom's genetics, dad's genetics, already all built in there. That these guys are all my buddies. Do not attack them. And then those bugs come in because they were persuaded to come in because of the food that you gave them through the milk, as well as the proteins that you produced in your gut lining. So there's a balance there. There's a symbiotic relationship. So what is this called? This is called a commensal relationship between the gut bacteria and the human being. So now we say, okay, so all my friends have arrived now, and I'm going to work with them, together with them, to have the chemistry that is needed to make this baby into a functional adult. Okay? So that's how the bacteria get in there. So if we take a course of antibiotics right at time of childbirth, has that been shown to have an effect on the baby? The answer is yes. Does it have an effect on the mom? Yes. Are you creating perturbations that are going to be bad? That, wait a second, I'm interfering with the bacterial population, and is that of any consequence? And the answer is a resounding yes. Now, we're getting into this in great detail, but does that mean that if you have had 5 courses of antibiotics before the age of 1, and you've practically destroyed your bacterial flora through these antibiotics, for example, or eating the wrong foods in the first 1 year or 2 years of your life, okay? If you're not fostering the growth of the right, has that any long-term consequences? And the answer are resounding yes. There's a high incidence of asthma, autoimmune diseases, rheumatoid arthritis, even type 2 diabetes, when these kids who have a disturbed microbiome from the age of 6 months or a year out to 35 years. Now, obviously, we're studying these patients as we go along, but in rats, you can study this much easier because they have a shorter lifespan. In animal models, 3 antibiotic courses within the first year of life, the equivalent of the first year of life, will have a lifelong effect on that baby's microbiome. See, there's certain keystone species which are going to be destroyed with antibiotics or lifestyle. And sometimes they never come back after a course of antibiotics. And by the way, most of these antibiotics are for viral diseases. Because we are compassionate physicians, we're concerned that we don't want to miss a bacterial infection in that baby. But even the CDC has said that up to 3/4 of antibiotics are really not for bacterial infections. They're for viral infections and probably should not be prescribed. So when you look at the growth of this diseases of modern man, maybe the roots are from the time we are born. Not only that, but when these kids who have a depleted or a microbiome that is not so diverse, when they go on to have their babies, that mom now has a baby herself. She's going to have a more depleted microbiome to hand over to her child. And when that child has a baby, there's even less microbiome for the next generation. And that's been shown over and over again, now not only in humans, but definitely in animal studies. That scares us because we're losing our keystone main bacteria that we're supposed to have in our gut. So does that have any consequences? Yes, not only these diseases, but even brain development. So wait a second. Are you saying that my brain development is dependent on my bacteria being there under the age of 1 while my brain is still developing, and it actually has an influence on my brain development? The studies have been shown, yes. The germ-free mice, if you introduce bacteria after a certain period of time, and they've missed that period, that critical period when they should have had the bacteria in their gut from day 1, those mice are never the same again. So developmentally, it appears that these bacteria affect our physiology. They produce certain chemicals that then affect our brain development as well. So it's a very complicated area of understanding that we need to be worried about what's happening to us now. Okay, I got coronary artery disease, and I have hypertension, I have diabetes, I'm going to change my bacterial flora, I'm going to eat right, I'm going to do what Dr. J tells me. Yeah, that's fine, but what about your children? What are we doing to them? Are we giving them the wrong foods? And then we worry about their atherosclerosis when they're 35 and 45 years old and they already come to me with coronary calcium in them? We should be working on the kids now to prevent them from getting heart disease when they grow old. And part of this is they need to foster this relationship with the bacteria the way you're supposed to be. You're a symbiotic organism, so you need that symbiosis. This is what I'm trying to do, to make people, not just with disease change, but change the next generation. Because if we do not do this, the chronic diseases are going to bankrupt, forget the country, it's going to bankrupt the whole world. It's going to be non-sustainable. But you may live longer, but your quality of life is going to be so poor. So these gut bacteria play a crucial role in our development. I already showed you how lipopolysaccharides affects you. So now I'm going to tell you a little bit about something else called short-chain fatty acids, which the bacteria produce in the gut. And we'll talk about the chemistry that's going on with the bacteria. What are they making? I told you they're making chemicals. Well, what are those chemicals? How do they work? Where do they go? We'll cover that in the next portion of this talk. If you like this video, then this one is strongly recommended for you. But if you want to see the whole series, please click here. It's your bacteria that are eating all that. They are the ones who actually benefit from it. They utilize that to produce then all the good chemicals such as short-chain fatty acids, which will then improve diabetes, make you reduce weight, decrease inflammation, more restful sleep. So welcome back. And we're going to continue this talk and talking about now the bacteria. What do they actually do that makes us so healthy? So it's a very vast subject. And my emphasis, of course, is inflammation and how it affects atherosclerosis in the humans. So let's dive into that just a little bit here. So I'm going to basically give you a schematic here of here's your gastrointestinal tract. And you have your lymphoid tissue sitting out here, the lymph cells. And these are all T cells and B cells and other immune cells. And there are other cells that actually sit right very close to the lining, and they send feelers out into the gut. And these feelers tell them who's there, which kind of folks are there, and whether they're friendly or not. And they talk. So they recognize these bacteria that are in here, and they send signals to the immune cells to say, hey, I'm a friend, I'm a friend. So this immunocyte says, okay, these are called Treg cells. They say, oh, my job, I'm a T cell, I'm a regulatory cell. That means I send a signal to all these other guys that, hey, when this guy comes along here, do not fight him. Do not raise an inflammation on him. Don't throw any bombs out at him. Okay. So Tregs, why am I talking about Treg cells? It appears that when you have a paucity of bacteria in the gut or the lack of variety in the gut, lack of variety of bugs, you don't have that spread of, thousands and thousands of different species that you're supposed to have, then you're not going to get enough Treg production or regulation of T cells. So if your T cell regulation is unchecked, then when a bacteria does get in, you're going to get a profound response because there's no Tregs going around. You did not get regulation. Regulation needs to happen from a young age. That's why what the baby starts eating is very important at a very young age. Because what's happening here in the gut and the variety of gut bacteria is going to tell your immune system, slow down. I'm taming the immune system. So the problem we see today is too much inflammation, too rapid fire, too quick to draw the gun and fire. And that's what's causing a lot of these diseases, atherosclerosis, inflammatory bowel disease, autoimmune diseases, even asthma and the like. These are all overactive immune system. A good immune system is not overactive. A good immune system is one that actually knows when it should go into war and when it should not go into war. So these dendritic cells and other T cells, they have a vital role to play with the gut. And the gut produces chemicals that affect these. But not only the chemicals produced by the bacteria affect the local T cells and B cells, they affect them systemically as well. So this is very important. Which kinds of chemicals they produce and which bacteria are producing the beneficial ones. So we know that the ratio of Firmicutes versus Bacteroides has to be just right for the system to be balanced. And you can do tests for that. And people can do stool tests and say, oh, your stools are mostly composed of this bacteria or that bacteria. And you can predict that person's weight. And you can even sometimes predict which diseases they have based on that. It's not 100%, but it's about 70% accurate at this time. You can actually predict what your body mass index is going to be, what conditions you're likely to have. But more important is not the species we're finding out, because we're finding out that it's what the genome of that bacteria is making. So it's the products. It's called the postbiotics. The postbiotics are the chemicals that are made by the bacteria that are more important. So they can be turned on genetically. They can be turned on through their epigenetics, just like how we have our epigenetics. Theirs can be turned on as well. So these postbiotics is what we should really be mentioning. So one of the key ones that I'm very interested in is what is known as short-chain fatty acids. These are produced by the very benevolent bacteria in the gut. What's it to do with cardiology? Well, these heal the lining. And we talked about earlier on that if your lining is leaky, you have a problem. Well, these produce the energy that's required for the endothelium itself, the lining of the gut itself. So it makes the lining healthier, more energy for it, and produces more mucus. So when there's more mucus lining the gut, there's a better barrier between the bacteria and your body. You want lots of mucus. For example, Akkermansia muciniphila, that's a type of bacteria that's very helpful in humans. It's been shown to be extremely helpful. Why? Because it produces certain chemicals, including short-chain fatty acids, that increase the mucus production. And it actually even eats some of that mucus itself, so it's self-serving. But with the excess mucus that's produced there, our gut lining is healthy. When our gut lining gets eaten away by the wrong bacteria, you're going to get leaky gut. So wait a second, you're saying that when the wrong bacteria are there, you have very little Akkermansia, you have a lot of bad species over there or bad products, the mucus gets all chewed up, gets eaten up. Yes, then you're going to get immune activation. Yes, you're going to get autoimmune disease, you're going to get inflammation. It's terrible. Terrible stuff's going on here. And you can also change your epigenetic expression of other molecules, other cells in the body as well through those bad things that happen. So the short-chain fatty acids improve the lining, they improve the mucus production, but they do other things too. The butyrate, which is the main one that I'm interested in, actually reduces systemic blood pressure. It causes in the brain, it's been shown to increase BDNF, which is brain-derived neurotropic factor, and it can heal the blood-brain barrier as well. So the short-chain fatty acids are very anti-inflammatory. And the more we make of these, the better and healthier the human being is going to be. So can we identify how much I'm making right now? Well, this study is ongoing. Unfortunately, we don't have that. So we can identify the species. How did that happen? Well, because we measure their genetics. So the Human Genome Project gave us the ability now to, in a matter of hours, you can sequence the DNA of thousands of species of bacteria in your stool. So it can be done. So we're identifying the species now, but we need to take it a step further. We need to identify what chemicals are being produced by those bacteria. But we have a pretty good idea already that, one, you need a diverse microbiome. What does that mean? That means stop killing them. You need a variety. You need thousands of species. If you look at the stools of a Hadza, let's say, for example, in Africa, who's eating mostly tubers and whole foods, he's got thousands and thousands of species of bacteria, and his stool weighs like 2 pounds versus 4 ounces that the modern man is making. I mean, 4 ounces versus 2 pounds. But 50% of the weight of his stool is bacteria, because he's making all that bacteria population very healthy. He's got a lot of bacteria in his gut. So we know that the more diverse the gut bacteria, the healthier the human being. You need to improve the diversity of your gut bacteria. If you're not going to do that, you're going to have multiple problems in your health. Take a guess. It'll go from the brain to the heart to atherosclerosis to joint problems to gut problems. Name it. You're going to get it. Multiple sclerosis also. Even type 1 diabetes. All been associated with changes in the gut flora. You need to have a diverse gut flora. Why? Because the good take care of the bad guys. You know, sometimes when you introduce a good bacteria and you get beneficial effects, it's not the good bacteria's direct effect. It's because that took care of something else, that took care of something else, and then finally this species was able to then increase. So it's very complicated. It's very complicated. Because otherwise you're going to say to me, well, Dr. J, why don't you just introduce the species? Give me some Akkermansia right now. I want lots of Akkermansia. I'm going to sip it all day long, breakfast, lunch, and dinner. You can't do that. You can't do that because it's a long journey to go to the gut, right? So it may not even survive that journey. So do I give a lot of probiotics to my patients to say, oh, yeah, you should take this probiotic and swallow all these capsules? And no, I don't. I prefer to give them foods that's going to bring those bacteria in, because everything you eat is going to have some bacteria in it. And then the good guys will stay behind. Even a small inoculation into the large colon will then grow it if the right food is there. So what do I say? I say eat whole foods, lots of different kinds of fiber, not just one kind of fiber. Now, I do give inulin to all my patients because I think they're never going to get lots of fiber in their diet. So I give them a soluble fiber called inulin. And the one I use is called inulin plus FOS. And what does that do? What that does is that it's the soluble fiber that comes from garlic and from chives and the like. And what happened? Artichokes. And it really, and you know that you're taking it because in the first few weeks you get some gas maybe, and you start noticing more grumblings, but then your stool becomes softer, easier to go. And you know, now there are changes. The bulk also increases. It's from 4 ounces to maybe 8 ounces. That's 100% increase in your stool weight. I mean, that's something. So I introduce the dietary changes. Number 2, stop taking all these chemicals in your diet. Like, for example, artificial sweeteners. So you can't digest artificial sweeteners, but guess what? The bacteria do. That's why it's bad for you. It's bad for you for 2 ways. One, the tongue sees the sweet taste and therefore already releases hormones in your body, and yet you're not getting the calories, and that's going to make you even more hungry. But number 2 reason is that the gut bacteria get demolished because they consume that substance and the bad guys consume it. And I told you need a good variety, and you want the good guys, not the bad guys. So you want to foster the growth of good guys, you need the right fiber. Don't give them artificial sweeteners, for example. You need lots of omega-3 because omega-3 stimulates intestinal alkaline phosphatase, which will then heal your gut lining as well. So you need lots of omega-3 in your diet, right? And you need to have a well-rounded, nutrient-dense food, including phytochemicals. All the different colors of foods, they're not for you. You can't digest those phytochemicals. It's your bacteria that are eating all that. They are the ones who actually benefit from it. They utilize that to produce then all the good chemicals such as short-chain fatty acids, which will then improve diabetes, make you reduce weight, decrease inflammation, more restful sleep. So how does the brain know that all this is going on down here? So I'm going to introduce you to another aspect that's going on here. Okay, this is very important, that the vagus nerve connects in a bidirectional way to your brain. This is so important, that the vagus nerve allows the brain to know what's going on over here, because there's neurotransmitters produced in the gut lining and also by the bacteria. So wait a second, you're telling me that the bacteria are making chemicals? Yes, of course they are. I told you they're making chemicals. That's one of them. But they can actually go to the brain? Yes. These chemicals can actually stimulate the vagus nerve and even travel up in a retrograde fashion to the brain. And the brain knows what's going on in the gut. And it then sends out signals in the other direction. So why is this important? Because the vagus nerve is also involved in the enteric nervous system, which is the electrical system of the bowels, so the bowels move forward and not backwards like reflux. So how do I treat reflux in my practice? I change the diet and the reflux gets better. Why? Because the enteric nervous system gets better. All those nerve endings get better and they start moving in the right direction. Yeah, they don't get retrograde propulsion, and the bowels are better, they feel better. And the vagus nerve is very involved in all of this in a bidirectional fashion. That is why when you are very stressed out and you're making a lot of corticotropin releasing hormone from your brain, it goes down the vagus nerve, it comes down here to the gut lining, and it goes on to the mast cells. And the mast cells release all the peptides, and then that causes inflammation in the gut. That's why when you're going through a bad exam or a bad day at work or something, your gut gives you more problems, because this is what's happening. The brain is talking to the gut, and the gut then talks back to the brain. There's this big gut-brain axis. And that's a whole talk in and of itself. Very interesting stuff. I'm more interested in your cardiology aspects. Okay? But how does this affect me in cardiology? Affects me because I see a lot of young people who come to me and they have orthostatic hypotension, or they have POTS, and which is a rapid heart rate, inappropriate for their activity. And I take a full history and I find out why the vagus nerve is not working properly. As far as I know, I'm the only one that's actually working on the gut as a way to fix your vasovagal problems that you're having. When you stand up, you get lightheaded, dizzy, your blood pressure is too low, your heart rate is too fast. Well, it's because your vagus nerve is dysfunctional. So if I can improve the state of the health in the gut, which means not just the gut lining, not just your colonoscopy, because that's just going to tell me that your lining is okay and you don't have cancer, you don't have diverticular disease. I'm more interested in the function of your gut, in your gut bacteria. I'll take a full history, your antibiotic history, everything else, and I'll change your diet. And lo and behold, they come back to say, you know what, I'm much better. I'm not fainting as often as I used to. And my pulse rate is now slower. And I'm sleeping better at night as well. All these are incredible benefits by improving your gut health through acknowledging that there's a whole bunch of chemicals and stuff that's going on in your gut here by all these commensal bacteria in your gut. This is very important. So there's nervous, there's immune system, nerves, and then of course there's the endocrine system. The endocrine system, we did talk about hyperinsulinemia, but that's a whole complex subject. But my main focus here is atherosclerotic inflammation, heart rate, blood pressure, atherosclerosis, and how I can modulate these things in my practice in this fashion. So In our next talk, we'll dive even deeper into some other aspects of why the microbiome is really the heart of your health. It really is the heart of your health. So we'll talk about that next. If you like this video, then this one is strongly recommended for you. But if you want to see the whole series, please click here. But these are practical steps that you can take today. Today you can make these changes. None of these are that difficult. You can. You just have to make up your mind. Do you want chronic diseases of man today? Or do you want to die when you are 98 years old, just walking down the street and dropping dead? Well, welcome back. So, enough of this chemistry, physiology, biochemistry, everything else. What can I do today to improve my gut bacteria so that my gut lining is also better, so that I have less inflammation in my body, so that I will not get the diseases of modern man. Modern man, from the industrialization. Since then, this has all happened. These are all new acquired diseases that we are now looking at. And it's our lifestyle. And this next portion, I'm going to talk about your lifestyle, which includes the microbiome, because it's all one big ecosystem in your body. So let's just dive right into it. What do I do practically with my patients? Of course, I take the full history, exam, everything else. But what's my final advice? Number one, fasting. Why do I tell them to fast? What's that got to do with the microbiome? Well, when you fast, guess what happens to the bad guys in your gut? They have nothing to eat. And I told you their half-life is really short. So they start dying off. So their population goes down. The good guys, their population stays good. In fact, it gets even better because the body wants to preserve those and produces chemicals to actually feed those bacteria. So there's a dramatic change in fasting in the bacterial flora. This has been shown over and over again. The fasting doesn't only benefit you in one way, that, okay, fine, I'm fasting, so I'm not taking any food inside. But no, your butyric acid levels go up, your ketones go up, your brain changes. It gets neuroplasticity and brain-derived neurotropic factors. But some of the ketosis and the changes in the biochemistry actually changes your gut flora as well. So it's very interesting that it's all linked in. So fasting does improve your gut flora. In fact, if you look at hibernating animals, when they are fasting in that state, there's a huge change in the microbiome that occurs. The microbiome changes in people who get gastric bypass. And we think that, gastric bypass, they're just eating less and they're eating smaller amounts. But no, we now know that most of the changes, the beneficial changes that are occurring after gastric bypass surgery is as a result of the microbiome changes completely. It's drastic change. That's how you get reversal of diabetes and obesity and all the other conditions associated with morbid obesity. And talk about obesity, I just want to throw in 2 points. If your BMI is over 40, you've just lost 7 years of your life. If your BMI is over 50, you've just lost 14 years of your life. This is not to be taken lightly. Obesity is just a phenotype of something that may be going on inside your body. It's not just, I'm obese. There are some patients that are obese, yes, and there's no inflammation in the body. When you look at the livers, and they don't have fatty liver, they don't have inflammatory markers, they don't have small dense LDL, they don't have atherosclerosis. And if I did a biopsy of their fat, it probably is not full of immunocytes. They're the minority. So we got to look at this in more serious. Obesity is not to be taken lightly. Not to be. If you want a functional, long life, then get your BMI down to normal. This is very important. So intermittent fasting, time-restricted feeding. Remember, your microbiome also has a circadian pattern. So if you're eating every 2 hours, you've shown no respect for the circadian pattern of your microbiome. So therefore, that microbiome is going to be stressed out. You're going to have the wrong kind. And that's been shown over and over again. You eat every 2-3 hours, and you're going to have a different type of microbiome than if you do time-restricted feeding. Because teleologically, through evolution also, you are not supposed to be eating every few hours. Go look at my previous videos on fasting to be convinced. You got to do time-restricted feeding. Okay, this is very important. So fasting, I think you can go look at my slides on that, but they do affect the microbiome and affects your inflammation. Fiber, whole foods. Look, you're supposed to eat whole foods. I thought that foods, okay, in the upper portion of the gut, it gets digested, hardly any gets down to the colon. No, you need to be eating for you and your bugs. So you say, this is for me. All right, this is a dessert. If you're going to have one, this is for me. It'll all be absorbed halfway down my ileum already. It's all gone. Nothing left to go down to the bottom. Sometimes some gets down and causes small bowel overgrowth, small intestinal bacterial overgrowth, because those bugs that love sugar, they flourish in that terminal portion of your ileum, and you get this condition. In fact, 61% of obese patients probably have what is known as SIBO. 61% of obese patients probably have SIBO. What does that mean? That means they have small intestinal bacterial overgrowth. The dysbiosis that's going on in your colon, now these bacteria go to a different place to live. They start living in the intestine and cause havoc over there. So those are the patients who get a lot of GI symptoms. And SIBO can be treated and can be treated effectively. It can be even diagnosed effectively. You can diagnose SIBO. You can diagnose leaky gut. So all these tests can be done. But the point here is that you need to be eating whole foods with a variety of different types of fiber in your diet. And we know this from our Mediterranean diets, from the diets of people who eat whole foods. They get the right fiber, whole foods. You look at the similarity of all the blue zones. What do they eat? So some eat not that much fiber, but everything they do eat is all whole foods. So because it's all whole food, it will then introduce and bring in the right bacteria as well. So the Inuits, for example, they don't eat that much fiber. But what they do eat, what little they do eat, fosters the growth of the right microbiome. Yeah. Fermented foods. I tell all my patients to eat fermented foods. Every day you should be eating sauerkraut or kimchi or natto, if you like natto. The Japanese eat a lot of natto. What is natto? Natto is fermented soy. You can play with it at home. You can ferment soybeans, and you can have that. Yogurt, of course, but I like kefir. I like kefir very much because I think that it actually gets down to the colon, and it has great benefit. The more the different varieties of bacteria, the better. And this is very important. Fermented foods. Supplements. There are some supplements that I give my patients to improve their gut bacteria. One of them is, of course, omega-3, because I told you that it produces or stimulates rather intestinal alkaline phosphatase, which actually heals the gut, so that they get less leaky gut. And I give some patients prebiotics, which are fiber supplements. Fiber supplements, which I mentioned inulin before, and then there are other fiber supplements that are also available, but I like inulin very much. But there are other prebiotics that are available for my very sick patients. They're basically made out of natural foods that are full of fiber, and then they put it into a little capsule form, and that's helpful. No processed oils. That means no omega-6 and omega-9, which is found in processed oils. So there's a separate talk on processed oils. That's not natural. You don't find that in nature. Yes, you find some polyunsaturated in nuts, for example, but the proportions are less. Even olive oil has some omega-6 in it and a little bit of omega-9 in it, but the proportions are much less. So nature, when it packages things together, it does it very nicely. So olive oil is not all monounsaturated as most people think it is. It's not. Only a proportion of it is polyunsaturated, and it's got monounsaturated in it. And there's even some saturated fat in it. So there's a mixed proportions in it, and everything is. Bottom line is, it must not be processed. Anything that comes from a factory is not right. If that oil was made in a factory, it's suspicious. So I don't know. Because what do they do? Because these oils will be consumed by your bacteria. But by the way, we in that big oil spill that we had in the Gulf, how did they fix it up? How did they clean it up? All that's oil, right? So along came bacteria to the rescue. It threw a bunch of bacteria that are oil-consuming bacteria, and they consume that oil. See? So bacteria can actually consume a lot of things. So if you live long enough, maybe in another million years from now, or 500,000 years from now, all the poisons that you're putting into your stomach, including plastics, for example, you will have bacteria in your gut that will be able to process all those bacteria, or all those products. But it's going to take you 500,000 years before you develop that type of ability. So I wouldn't wait that long. Processed food. No sweeteners, no preservatives, emulsifiers. Look, these things are all chemicals. They were made to preserve things for convenience, shelf life. That's why the processed oils are also used, like cookies, for example. Emulsifiers. Terrible. Hate emulsifiers. What is an emulsifier? An emulsifier is doing something that's unnatural. It's taking oil and water and putting it together, and it's emulsifying it so that it stays together. It's processed. Emulsifiers do terrible things inside your gut. Does the same thing. You're supposed to separate these things out. Emulsifiers, no good. No sugar. Sugar is a processed food. It's taken up by bad bacteria in your gut. Eat a lot of sugar, you got a lot of bad bugs in your gut. That includes high fructose corn syrup, which is really awful. Did you know that the metabolism of high fructose corn syrup is almost identical to alcohol? If your kids are taking high fructose corn syrup, you might as well give them a drink. It's that bad on the liver. So think twice before you give a kid any high fructose corn syrup. Fatty liver is one of the biggest problems that we have in kids today. And they're going to go on to get liver failure down the road. There's absolutely no doubt about it. True allergy workup. So some patients really have gut allergies, and that's why they have leaky gut. Yeah, and they may have gluten allergies. So you can do a gluten test, see whether they actually have gluten sensitivity or not. Sometimes it's the protein that's found in wheat or barley, rye, and oats. But you can run those tests on some patients. But you know what? In my experience, doing this now for a few years now, I find that the allergies is a little overblown. And a lot of people are going on to this gluten-free diet and saying some are feeling better, some are not feeling any better. They go on a gluten-free diet and then they're eating processed foods because there's a lot of processed gluten-free foods. So, you know, if you think you are gluten sensitive or allergic, just do the blood test. It's a clear-cut, nice blood test that's available. And then you can do some exclusions. That means you do everything else, you exclude one group of foods and see how it is. So you gotta have patience and have a provider that's going to work with you to see whether you in fact have a true allergy or not. Next one is sleep. Now, what's sleep got to do with the bacteria? Do bacteria need sleep? Answer is yes, they have a circadian pattern as well. And sleep will change your autonomic condition, will give you sleepy, leaky gut. So one night of no sleep, bad sleep, increases LPS levels in your blood. Bad sleep patterns are inflammatory. There's no doubt about it. We know that. There's increased sympathetic output from the brain. As far as the gut is concerned, you do get leaky gut. So you really have to repair the gut lining. To do that, 7 hours of good sleep. If you're not waking up in the morning feeling refreshed, there's something wrong with your sleep. You need to go see a good sleep physician. Now, that doesn't mean you have obstructive sleep apnea only. Sleep hygiene is important. Sleep apnea simply means that, okay, you're choking at night because of your increased body mass, or maybe your turbinates are all blocked and you've got nasal congestion at night. And by the way, this is happening in kids too. Huge problems with sleep. Why? Because their guts are leaking, and therefore they're getting inflammation. They're getting mucosal thickening, they're mouth breathing. As a result, there's inflammation. There's a difference between nose breathing and mouth breathing. Mouth breathing causes inflammation. Inflammatory markers go up. So these kids are becoming inflamed and they're getting obstructive sleep apnea at night because their noses are getting blocked, the congestion. That's why they get so much infection in their ears as well. So if you get a child that's constantly nose is blocked, get it checked out and get open. Do not accept mouth breathing. It affects their sleep patterns at night. It's going to affect their learning. And remember, there's a There's a phase that you go through. If you don't learn it now, it's going to be very hard to learn later on. It's lost years. Sleep is not to be taken lightly, especially in children. So in adults, of course, it's very important too. If you have sleep apnea due to obesity or due to structural problems, you can take care of it. You can even sleep with a mask temporarily. But of course, the real treatment for obstructive sleep apnea in adults is weight loss, dietary changes. But your sleep hygiene is important. Watching blue light at night decreases the quality of your deep sleep as well. So, you need to start dimming the lights and you need to allow your body to get into that restful state before you go to bed. Stress management. Can stress increase gut leakiness and inflammation and inflammatory markers such as LPS? And the answer is a resounding yes. So you just have one bad, stressful day, you've just had a bunch of LPS go through your body. But it's so important. That is why everyone must learn some form of relaxation. Meditation is an excellent one. It's a lovely way to manage stress. And in it, I also added biophilia. So do you know what biophilia is? So biophilia is a great word. Bio means life, or the environment. Philia means love. So when you go for a walk in the mountains, in the hills, or a meadow, or a park, or even on a beach, why do you feel so good? Is it just because, I went out for a walk? No, because you could have gone for a walk in the concrete jungle of downtown, and I don't think you'd feel that good. But biophilia is something special, a feeling of restfulness, of wonderful feeling that you get. Why is that? It's because you're also getting bacteria out there. With every breath that you're taking in millions of bacteria. Did you know that? I mean, you think that we are so clever here. We wash our hands with alcohol and we have this AC going on and everything else. But actually, the air in here is not as good as the air outside. You're actually absorbing, taking in bacteria. You want that because you want that biodiversity in your body, because the body is always looking to say, okay, how can I become stronger? How can I become better? Each breath that you take in takes in millions and millions of bacteria. One drop of ocean water has 1 million bacteria in it. Maybe that's why you're feeling so good when you go for a swim in the river or go for a swim in the ocean. Because your biophilia gives you the microbiome changes that you're going to need to optimize it. What's missing? Okay, these guys are missing. They all come in. These guys I got plenty of. I don't need these guys. 99.9% of the bacteria out there are harmless to human beings. But we've treated them like enemies, and we've tried to demolish them by starving them out and killing them with antibiotics. And unnecessary, agents such as these hose pipes that are made of these special type of plastics that kill bacteria. Why? What are you going to achieve by doing that? See? So biophilia is really important. Putting yourself in the environment, changing your environment, very important. Exercise. Now, exercise we did talk about a little bit. So why is exercise so helpful? Does your gut flora change when you exercise? The answer is yes. So we know the exercise is good for the cardiovascular system. Did we work it out exactly why? Nobody really knew exactly why exercise is so beneficial for cardiovascular disease. Yeah, having aerobic capacity is very good so that you don't get anaerobic and your heart rate doesn't go up too much and your blood pressure doesn't go up too much, so you can get the same wattage of work done with less effort. So you need cardiac fitness. Okay, but that's different from the biochemistry of your arteries. To make your biochemistry better, exercise also helps, makes the blood vessels better. How? One of the ways it does is butyrate. So when you exercise, you're actually making butyrate, and butyrate actually improves the condition of your blood vessels, and it actually it's anti-atherosclerotic. Hormesis. Why did I throw hormesis in there? Hormesis is a kind of a stress that the body goes through, and that hormesis actually improves your body for the next adventure. Does exercise change your gut bacteria also because it's a form of hormesis? And the answer is yes. So what happens is, let's say I go for a 4-mile walk or 3-mile walk. My body language is as follows. He's changed his environment. He's gone to a new place. And a new place is going to give him new challenges. So I got to prepare for this. And a new place is going to have new bacteria. I need to prepare for that. See? So it makes changes in the body, including your microbiome, because it anticipates that there's going to be a new environment and I got to be better able to handle this new environment. That's how your body knows. How did your body know? What are the markers that told it that there's change in a place that I'm in? So it's trying to maintain homeostasis. So whenever there's some degree of challenge to your homeostasis, there's going to be an improvement in your immune system. And atherosclerosis is an immune problem. It is an immune problem. It's an inflammation problem. So hormesis is necessary. Some form of stress, exercise. Fasting is hormesis. What else do I do? Besides fasting and exercise, I do hot sauna. Okay? Sauna has been shown to reduce sudden cardiac death by more than 50% if you do it 3 to 4 times a week. And yeah, it's got to do with heat shock proteins and everything else. I don't have data on the gut bacteria. But if you're interested in research, and it seems like you are, then go and do some research on that. I bet you'll find that eventually they're going to find that sauna also makes changes to the gut lining and your bacterial flora. That's how it is anti-inflammatory. So some form of hormesis. You got to have some form of... And if you just sit around all day doing absolutely nothing, you sit in one spot for weeks after weeks, your immune system's all going to go down. The next bug that comes along, whether it's pneumonia or whatever, bingo, you're going to get it. You're going to get it. You're going to get the illness. And you're going to get a cytokine storm because your immune system was not regulated to say, okay, don't overreact, don't overreact, don't overreact. Remember the Treg cells I told you about? Remember the Treg cells in the intestines? Regulatory cells. These Treg cells are very important. They actually go to your thymus gland as well, and the thymus then, especially during development, that's the master that says, okay, all these following antigens, these are all friends. Don't react to them anymore, okay? Now go out and tell your immune system this answer. And they go out there and tell the whole body, hey, I got a whole bunch of friends here. You don't react to these guys, okay? Don't react to them. These are my friends, Tregs. And that's the homeostasis that we're supposed to be living in. And that's what this is all about, is maintaining that homeostasis. So you need to stress it every now and then a little bit, because what doesn't kill you strengthens you, right? Somebody said that. So there you go. So I hope that this was helpful about what I practically do in the office, because understanding the biochemistry of this is of course, very complicated and coming up with more and more. But these are practical steps that you can take today. Today you can make these changes. None of these are that difficult. You can. You just have to make up your mind. Do you want chronic diseases of man today? Or do you want to die when you are 98 years old, just walking down the street and dropping dead? Because that's what I want to do. None of these chronic diseases and disability. We don't want that. Mentally also. You should be afraid about Alzheimer's. Alzheimer's. Let me tell you, Alzheimer's is all inflammatory. It's mostly inflammatory. And you want to fight Alzheimer's, you do this. Can't guarantee you won't get it, because there are other forms of Alzheimer's too. But I'm telling you, you'll make a huge dent in your probability that you get Alzheimer's. So don't get Alzheimer's, don't get physical illness, don't get coronary artery disease, don't get end organ dysfunction. Yeah. Keep your muscles strength, grow your muscles, keep them, sleep right, fix your gut bacteria. We'll catch you on our next trip. If you're coming on my next trip, it's going to be on the USS Enterprise. So I hope that you all can join me. Till then, be safe. If you like this video, then this one is strongly recommended for you. But if you want to see the whole series, please click here. So then it comes down here, and then it comes into all the gut area here, okay? So in the gut, it breaks down by the stomach into 2 branches. One goes to the front, one goes to the bottom and out, and it goes down to your colon. So why am I so interested in what's going on in the gut down here? Well, you all know I'm very interested in the gut. Why am I interested in the gut? Because there's another huge representation that my vagus nerve in my gut will affect my brain and can affect my heart as well. And my vagus nerve over here is going to affect my leaky gut and my microbiome as well. And I already told you all that I believe that all inflammation starts in the gut. All inflammation starts in the gut. So anything to do with the gut, including the vagus nerve, is of interest to me. If I can hack your vagus nerve and make your gut work better, you will have less metabolic endotoxemia. That means your leaky gut will be less. Therefore, things that should stay in the sewer will stay in the sewer and not get into your bloodstream. If you have a leaky gut as a result of dysfunctional vagus nerve, or your vagus nerve is not working properly for multiple reasons, which I'll show you in a minute, you're going to get more leaky gut. If you get leaky gut, you get lipopolysaccharides and interleukins and other inflammatory molecules getting out from your gut into your bloodstream and then going to your whole body and causing inflammation. Chronic inflammation. Most diseases today are chronic inflammation. Look, you guys are not dying of dysentery or leprosy and all those bad things, right? So it's very important to understand this chronic inflammation. Where does it come from? Where does most inflammation come from? It comes from your gut. Now, sometimes we also do bad things. We put things on our bodies and whatnot on our body. But things comes from your gut. That's the biggest threat you have. You have what? 100 trillion bacteria in your gut. And not only that, but you got the wrong bugs in your gut. Fine, you got 100 trillion, fine. But you got the wrong ones there. Why? Because you killed off the good ones, right? So when the bad ones are in your gut, what are they doing to your vagus nerve? They're stimulating it. They're making it dysfunctional. So when those bacteria produce bad substances, neurotransmitters, they'll go up the vagus nerve and they can travel all the way into the brain. Now that should scare you. Do you want your bacterial products to travel up all the way to the brain? So there's a strong correlation between what's going on in the gut and some of the neurodegenerative diseases, which is a whole new topic we can talk about, such as Parkinson's and also with other movement disorders. So Parkinson's is huge. A lot of Parkinson's going on. Everyone knows somebody who's got Parkinson's. Dementia, inflammatory conditions in the brain. How did they get there? Well, these things can get in through the blood and they can cross the blood-brain barrier. But they can also get direct entry into the brain through your vagus nerve. Did you know that? That you can actually get direct entry into your brain through your vagus nerve. And there are studies now showing that particles that were found originally in the intestine ended up in the brain via the vagus nerve. So I say that the vagus nerve here is very important. Plus, you got to remember, when you have the wrong bacteria or you have inflammation in your gut, or let's say you have food sensitivities, like you're allergic to wheat germ agglutinin. Oh, it's horrible. Wheat germ agglutinin is the number one thing that I'm finding in my patients who have either got autoimmune diseases or coronary artery disease or hypertension, metabolic syndrome. The one thing I'm finding is wheat germ agglutinin allergy. So it's really a sensitivity. It's not gluten only. People think of celiac disease. No. So what happens with wheat germ agglutinin is it causes inflammation here in the gut. So the first thing that's going to get affected by that, or one of the first things that's going to be affected by the inflammation in the gut, is the nervous system in your gut. It's called the enteric nervous system, right? That's the nervous system of your gut. After the brain, the second largest neural network is in your gut. Now, if it is supplying your intestines and your intestines are all messed up, what's happened to that vagus nerve, enteric nervous system? It's messed up. So it's sending wrong signals to the brain from the gut. And those signals, remember, it's a two-way channel. So they're going up and down, and in between there's your lungs, there's your heart rate. No wonder you get all sorts of vasomotor and vasovagal symptoms when you have gut problems. I'll give you an example. A patient came to see me the other day, and she had what is known as POTS. So she had a very high heart rate all the time, and when she stood up, her blood pressure would just drop all the time. Why? Because she got autonomic dysfunction. Because look, when you stand up, your autonomic nervous system is supposed to fix everything, right? It's supposed to fix everything by vasoconstricting you. Well, she had inappropriate sinus tachycardia all the time. She also had POTS. So in talking to her, I started concentrating on her gut. And she said, "Excuse me, I thought you were a cardiologist." I said, "I am." But it turns out that she had classic symptoms of small intestinal bacterial overgrowth. And I treated it. I gave her some of my herbal preparations, no antibiotics. I just gave her the herbal preparations. And she came back a month later. She's saying, "Oh my God, I finished this." And I, of course, put her on some quercetin and some curcumin later on and some other special essential oils. And she got better. And she says, "I'm no longer fainting. My heart rate has come down. I feel like I did before. It's so good." I fixed her heart rhythm through her gut. And I'm saying this all the time. That arrhythmias, blood pressure anomalies, especially orthostasis, autonomic dysfunction, because this is autonomic nervous system, starts in the gut. You fix the gut. You hack your vagus, fix your gut, hack your vagus, and your autonomic nervous system will reset itself back to where it should be. So you're no longer running sympathetic all the time. So the gut is really, really important, your enteric nervous system. So when the enteric nervous system goes wrong, the nerves of your gut, what symptoms are you likely to get? Constipation, because it's just not working, or diarrhea, where it's working too hard. It's dysfunctional. You want to fix that? You need to fix your gut. The enteric nervous system will get better. When the enteric nervous system gets better, your bowels come back to normal. And your diarrhea goes away, or your constipation goes away. You've got to fix the enteric nervous system. The nervous system in your gut is the vagus nerve coming down and spreading it. And this vagus nerve, it is such a vagabond. Literally every millimeter or so in the gut has one of its endings. So you've got to ask yourself, what's it doing there? It's feeling everything out, and it's sending back signals to the brain. And we just underestimate this whole thing. We definitely underestimate this whole thing. Hack your vagus nerve, those enteric nervous system will get better. Your gut will get better too. You having any type of GI symptoms? Start hacking your vagus nerve today, and tell me if your gut symptoms didn't get better. Now, of course, some gut symptoms are not only due to enteric nervous system, they are due to bacterial overgrowth, like that girl I was telling you about. Right? She had SIBO, and others have food sensitivity issues where they need to stay away from certain foods. So we do the blood tests to see which foods are you sensitive to. We do that. If they're having real bad bowel problems, then I check their stools to see which bacteria are missing or which ones are in excess, or what can I do to rebalance them. And then we give them fermented foods. We give them high doses of fish oil. So wait a second, what does fish oil got to do with all this? Well, fish oil has omega-3, and guess what's all these neurons made up of? Omega-3. So wait a second. If you're not having omega-3 in your body, or enough of it, and I know you don't, right now I'll tell you you don't, you've got a vagus nerve that's not working optimally. I'll just tell you that right now. You see, our omega-3 levels today are so low, it's unreal. I have yet to see maybe 1 out of 40 labs that come back with the omega-3 levels are optimal. It's called Omega Check. Nobody even checks for it. And the worst part of it, it's not just omega-3, they have too much omega-6. So it's not just omega-3, it's the ratio of omega-3 and 6. So if you have a relatively low omega-3, it's okay if you also have very low omega-6. Because it's the ratio that really matters more than anything else. But these days, we are all toxic with omega-6 because we're all eating vegetable seed oils. And then we eat nuts that have been roasted in vegetable seed oils. And we go out and eat too much, and all they use is vegetable seed oils. And you're paying for it too. and tipping them on top of it. Too much omega-6, too little omega-3. Omega-3 is needed especially for one big nerve in the body, and that's your vagus nerve. That's your vagus nerve. You've got to have omega-3. You have to take omega-3 supplements. Now, if you're a total vegan and you can't take fish oil, well, where does omega-3 come from, by the way? Oh, it comes from fish. Well, actually, it doesn't even come from fish. It comes from algae. And the algae get eaten by small fish, sardines, all those, and then they get eaten by bigger fish, eventually gets to you. The farm ones have no omega-3 in it, because I don't see algae down there anyway. So you got to be careful about just hoping that you're getting all your omega-3s from fish. Good luck, unless you're really eating only wild-caught salmon every day, and then also you got to eat a lot of it. But then, you know, that's not my advice. My advice is, look, it's easy. Hack the system. Just go and get omega-3 supplements and make sure that it doesn't contain PCP or dioxin or mercury. So you get a high-quality fish oil. If it smells bad, it's no good. If it tastes good, it's probably okay. It mustn't be rancid. And once you get it, put it in your refrigerator so it doesn't get rancid. Rancid means what? Oxidized. Because if fatty acids get oxidized, they're really bad for you, right? It causes small dense LDL, it causes lipid peroxidation, blah, blah, blah. All the things we talked about on other shows. But bottom line is, you want a healthy vagus nerve. A healthy vagus nerve is full of omega-3. And you must hack it frequently. Constantly hack your vagus nerve. Then that pathway will be facilitated, as we call it. So here we go. So it stopped here. Oh, yeah, okay. I saw another girl the other day. She was having gallbladder issues. So her gallbladder wasn't working. So what innervates the gallbladder? The vagus nerve, right? So with her, we did the same thing. We worked on her gut. And they said they were going to take her gallbladder out. And I said, yeah, well, you've got to follow the instructions, but just try this. And she did, and her symptoms got better. So she didn't have a gallstone. So what was the problem? She had a lazy gallbladder. So they give you this little medication, and then they look at your contractions on your gallbladder, and her gallbladder just wasn't contracting properly. And sure, that'll cause a lot of problems, right? So my solution for that was, listen, just wait a month. Try this. And we worked on her gut. And we worked on her motility and her vagus nerve function. And she did exercises, vagal nerve exercises, and she still has a gallbladder. So I just think that it's very important. Now, I'm not saying that all gallbladders must stay in even if they have stones. No, I'm not saying that. I'm just saying that there's lots more that meets the eye. Let's just be a little sensitive about this too. So if you enjoyed this short segment, here's another clip that I think you'll really enjoy. And if you'd like to see the whole video, then click here.